Hello, everybody. Welcome to Math Lesson 3.1. We are in topic 3 of Unit 1 now, so we're almost done with this first unit, which is fantastic. We are moving into division this time, and we're going to be talking about some strategies that you're probably familiar with, but maybe not in a division setting. So we might be kind of flipping things on their head a little bit, but I'm going to go over two different strategies for today. We'll talk about those, and then we'll keep talking about some other strategies as we continue going through our division section of this, this unit. All right, so let's start out by talking about what division problems can look like. Okay, so let's say if I have the problem, I'm going to use the problem 170 divided by 15. Okay, when you were in primary grades, this is probably what you saw, or even last year, you probably saw this pretty often. Okay, you might have also seen this type of division problem. Okay, these are both division symbols. Both of these means that we are dividing. It's just different formats of showing the same type of problem. This one is usually easier for doing smaller types of problems because you cannot do long division using this kind of method. You'd have to rewrite it. This one is already formatted so that you can do long division. And we will get to that. We'll talk about it. Parents, if you know the standard algorithm for using long division, I promise we will get there. We're just talking about what's happening in that problem first before we go over how to actually do the standard algorithm. All right, so let's go over what's happening in these problems here, okay? These are some important vocabulary terms that you are going to need to know. So please make sure that you are writing these down. We're going to be talking about these a lot as we talk about division. So make sure you're familiar with these different terms also. So let's start with our big number. So in division, our big number is called the dividend. Okay, now the dividend is going to be the total amount. It's the big number. It's how much you already have. Okay, so I'm gonna explain that as the whole of how much you have. Okay, over here, again, the big number is still the dividend. Okay, the terms don't change depending on which format you're using. They're both the dividend. Okay, now let's talk about the other term, this 15 here. Okay, this is what we are dividing by. Okay, and that is called, I'm going to put it up here so I have space. That is called the divisor. Okay, if you are familiar with the word divisive, that's usually someone who is breaking people apart or dividing groups. So I think of this number is divisive. It's the divisor. It's the one that's dividing the group, the whole total. Okay, so that's the divisor, which is what you are dividing by. And I'll point to it over here too. Okay, divisor, divisor in both cases. All right, now our last one is going to be our answer. Now the answer, like when we are doing an answer, ooh, I didn't want to do that. Sorry. All right, I'll leave it like that. Our answer when we are doing a multiplication problem is called the product. So it does have a special term for whatever the answer is. In division, it's not the product. It is called the quotient. And I know that's kind of a random word. You're like, where did that come from? You know what? I don't even know. I could probably look it up and do some research on the word quotient, but honestly, I just don't have time right now. If any of you would like to do that for me, let me know where the word quotient came from. Go for it. That would be awesome. But really, it's just a fancy word of saying the answer. Okay, if you're in this problem, your quotient is on top. If you're on this type of problem, your quotient is just right here at the end of the problem. Okay, so quotient is our answer. Dividend is our large number of how much we have total to start with, and the divisor is what you are dividing by, okay? All right, now let's look at, switch pens here. Let's look at an example problem. So, let's do this. One of the ways we can think about this problem, we're just going to be working with this problem a couple different times. You can see how I break it down in several different ways. Okay, so we're going to be using 170 divided by 15 a couple times. So one of the ways we can think about this, when you're thinking about division, division is the opposite of multiplication, right? It's reverse multiplication. So one of the ways you can think about a division problem is by thinking of it as reverse multiplication. So I'll write that out here. If I have 170, that's my big number. That's the total of what I have in my multiplication problem. That would be my product. That's the total, it's my answer. So 170 would be equal to my dividend times some other number. So 15 times some other number is going to get me 170, okay? Now, I don't know what this number is. That's my answer here in my division problem. So this is not known at the moment, okay? We're gonna figure it out. So what I'm gonna do is I'm gonna put a letter there. I'm just gonna pick the letter N, okay? Letter N, and that is called, actually, that's a term. That is called a variable, okay? It's basically a placeholder for a number that we don't know yet, okay? And I know parents, some of you might be thinking, well, a variable can actually change. It's not going to be one specific number. You're right. But in this case, in this math that we're doing right now at this level, this is not going to change. I'm just plugging in a variable to fill the spot of the number I do not yet know. Okay, so this variable is, we'll say a number not yet known. And I'll put in parentheses, we will figure it out. All right, so if we're thinking of this division problem in terms of multiplication, this is going to be called, run out of space already. This type of problem would be called reverse multiplication. Okay, I'm taking this division problem, I'm turning it into a reverse multiplication problem. So my product is coming first, and then my two numbers that are being multiplied together are behind it. And one of them I do not know yet because that was the unknown number from my division problem. All right, so using this, how am I going to turn this into an answer, basically? What do I have to do? So if you think of, let's see, if we're thinking of, let's think of multiplication first, okay? When we are doing multiplication, one of the ways that you guys were probably first introduced to multiplication was the fact that multiplication is repeated addition, right? So if you're trying to do 4 times 5, okay? You have 4, 8, 12, 16. Sorry, I can't lift this finger without my pinky going up. It's a weird thing that my hand does. See, it won't work. I've told it. So it's 16, and then one more would be 20, right? So I just counted 4 5 times. So I just repeated my addition. 4, 8, 12, 16, 20, right? That's my repeated addition. So if multiplication can be known as repeated addition, well, then we're just going to switch that. Division is the opposite of multiplication. So what's the opposite of addition? Well, that would be subtraction. So let's try and look at this problem as repeated subtraction. See if we can get an answer using that. All right, so repeated subtraction. So what I need to do is start with the big number, my total, okay? I'm always going to start with my biggest number when I'm doing subtraction. If I start with my smaller number and try to subtract the bigger number, it's not going to work because I'm going to start getting into negatives, and we're not there yet. So what I'm going to do is start with 170. That is my total number. And now what I'm going to do is I'm going to subtract groups of 15 as many times as I need to until I get to my answer, okay? So starting with 170, I'm going to take away 15, all right? Because I have a 15 here, so I'm taking away groups of 15 repeatedly. However many times I take it away is going to be this number here, all right? So 170 minus 15, let's start there. That would be 155. I'm going to keep going. 155 minus 15, that would be 140. 140 minus 15 would be 125. 125 minus 15 would be 110. 110 minus 15. Oops, I wrote 19. I was thinking ahead. My bad. 110 minus 15 is 95. 95 minus 15 is 80. 80 minus 15 is 65. 65 minus 15 is 50. 50 minus 15 is 35. 35 minus 15. Can you still see this? Yes, okay. 35 minus 15 is going to be 20. 20 minus 15 is 5. Okay. Now, I cannot continue subtracting. All I have here is 5. If I take away another 15 from 5, I'm going to start going into negative numbers. And again, we're not going there right now. Okay, we're not going into negative numbers when we're doing division. So what I am going to do, though, is I'm going to look at how many times I subtracted 15. Okay. Okay, so what I am looking for here is how many times I had to subtract a group of 15. Okay, so I'm going to count this up. I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times. Okay, so I had to take away 15 11 times. So that's 11 groups of 15. However, I don't want to forget about this number down here, because I didn't end on a perfect 0. So that means I didn't take away all parts of 170. But I can't take away another whole group of 15 because that will take too many away from the 5. It'll be too much and I'll go into negatives. So what I'm going to do is I'm going to write this as 11 full groups of 15 with a remainder, and I'm just going to put R, of 5. Remainder 5. I'll even write that out. Down here, this is a vocab term. That 5 that's left over is the remainder. It's whatever is remaining, but cannot be another full group. Okay? So 11 with remainder 5. And if you're like, wait, how can you have a remainder? Think about it like this. Actually, I'll draw it out down here with a different color. Think about it like this. If you and your friend, I'll give you an example, me and my sister, when we were growing up, if my mom made 5 cookies, okay, and she said, okay, you and your sister have to split them. Okay, so there's 5 cookies. 1, 2, 3, 4, 5. Okay, and they're splitting between me and my sister, which is only 2 people. Well, I could get 2. Rachel could get 2. That's even. Then we have 1 cookie left over still. All right, now this cookie did not disappear, but I can't make another full group of 2, right? So what I need to do is I'm going to have to figure out a different way to divide this up. This one is what is remaining. So we'll just call that, that's our remainder in this little cookie problem, okay? We still have it here, it didn't disappear, it's still there, but we can't put it into another full group. So it is the remainder, okay? That's what we're thinking of with this number here. We can't take away another full group. However, it is still there. This number did not disappear. We still have this 5, so we call it our remainder. So the remainder of 5. 11 groups, remainder 5, okay? So this repeated subtraction method, okay, this is absolutely a way that you can solve a division problem. You can definitely use this if you are comfortable with this, if you think it makes sense to you, then that's great. The issue with this one, and this is the reason why I don't usually do this, well, I guess there's 2 for me. One, I think it just takes a long time to take away each group, you know, taking away 15. This isn't even too bad of a problem, but we're going to be using much larger numbers, and eventually you're not going to have enough space on your page to do repeated subtraction for every single one. It's going to take a very long time. So that's one issue with this strategy. And then the other one is if in the middle of your subtracting, if you accidentally mess up, like right here, I was thinking ahead to my answer and I almost wrote the wrong number, which means I could have written the wrong answer here, it would have thrown off everything after it. Okay, so one mistake of subtraction anywhere in your problem is going to throw off your answer, and your answer is going to be wrong. Okay, so if you're not doing your subtraction perfectly, which we all make mistakes, sometimes we rush, sometimes we're thinking of something else and we write the wrong number. Okay, if we make a mistake, it's going to throw off your entire answer. So it's a little hard to make sure that this is going to be perfectly accurate without double checking every single thing. And again, that just adds more time. So this is absolutely a method you can use to solve a division problem. Okay, it can be accurate. You just have to be paying close attention and be careful with your subtraction, making sure that every single one of these is accurate so that your answer is not thrown off. Okay? All right, let's look at another strategy. Actually, let me do it here. Okay, so this next one, we're going to turn it into a word problem. And we're going to use a different strategy, but we're still going to use the same numbers because I want to show you more versions of the same problem, 170 divided by 15. Okay, so I'm still going to use those same numbers. So, you know what, I'm going to use a real life example here because, as I think almost all of you know, I just got married a few months ago. And when you get married, you have to do a lot of math. And one of the things I had to do was figure out table seating for all my guests at the reception. And I had to do some real life division to figure that out. So let's turn that into a problem. We'll say, at a wedding, my wedding, there are, I'm going to use those same numbers from before, 170 guests. There are 170 guests, and each table seats 15 guests. Okay, now those are pretty big tables. Mine did not seat that many, and so my numbers were a little bit different than this, but it's the same type of problem. We're trying to figure out, I have this many total guests, and each table can seat this many. Now my question is, how many tables will we need? All right, so before I get started, I want to label the different parts of my problem here, okay? My total number, the big number that I'm starting with, right here, that is my dividend, my big total number, okay? The number that I'm dividing by, right here, is my divisor. He's being divisive, and he's breaking apart that big number, okay? So What I'm going to do with this problem, I'm using the same numbers, but I turned it into a word problem here so we can kind of draw out what's happening in this actual problem. So what I'm going to do is I'm going to draw out groups of 15. Okay, I'm going to kind of go the opposite way. Instead of doing repeated subtraction where I start with my big number, I'm going to actually do repeated addition until I get up to my big number. Okay, so here's what I'm going to do. I'm going to draw out, I'll just do a big table like that. I'm not going to draw each person around the table, but I will say that each one seats 15 people. Okay, so that's one table, 15. All right, well, that's not up to 170 yet. That's going to leave out a lot of guests. So let's keep going. Another table, another 15. Okay, now we're up to 30. I'll put my total on the bottom here. Another table. My circles are going to get smaller and smaller. Sorry, guys. 45. Another 15, that's 60. Another 15, that's 75. Another 15, that's 90. All right, I'm still not at 170, so I'm going to keep adding tables. Another 15, that's 105. Another 15, that's 120. Another 15, that's 135. Okay, I'm getting closer. Another 15, 150. And another 15, 165. All right, I'm getting close. I'm almost there. So I have this many full tables so far. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 full tables, okay? Now, if I add another table here, okay, if I add another 15 to this, I'm just trying to get up to the number 170, okay? If I add 15 more to 165, that's going to be much higher than 170. That's going to be 180. So I don't need another full table here, but I also can't leave off those last few guests, right? This is only 165. I have 170 guests. I cannot leave out any guests like my Uncle Sam or someone, and I need them to be still part of my wedding, so they need a place to sit. So I can't forget about those people, right? They still need a place. However, they're not going to fill up an entire table. So instead of filling up this whole thing, let's figure out how many more I need just to get up to my total. I'm at 165. I need to get to 170. So that's 166, 167, 168, 69, and 170. 5 more. So I only need 5 at this last table, and that will bring me to my total of 170. Okay, so what I did here, or what I found out, was that I would have, or I would need 11 full tables, but with 5 people left over. Okay, now in the case of this word problem, those 5 people are not just going to stand in the corner, they still need a place to sit. So I'm actually going to need 12 tables will be needed in all. We're just going to have to know that that last table is going to have some extra space at it because it is not a full group of 15. Okay, so another way I could write this, what I found out here was that 11 full tables with a remainder of 5 people. Okay, in my word problem, that means 12 tables because these people need a place to sit. But in what I found with my repeated addition here, I have 11 full groups, and then I have 5 more left over. Okay, so that would be a representation of drawing repeated addition. Okay, so I basically took my division problem up here. I kind of flipped it around into an addition problem, a repeated addition problem. And I just did 15 over and over again until I got up to my total. Okay, then I was able to count up my groups and figure out, okay, 11 groups, 5 left over. That would be 11, remainder 5, just like we got on our first page when we did repeated subtraction, 11, remainder 5. Okay, so 11 full groups with 5 left over when we are dividing those numbers. All right. Okay, so that's our first introduction to some of our division strategies. I know both of these tend to take a little bit longer, but what we're trying to do is make sure that you guys fully understand what's happening in a division problem by drawing it out or working it out with more steps before we get to more of those shortcut methods. Because when we learn the shortcut methods first, we just tend to stick with that and never truly understand what we are doing or why we are doing the shortcuts. So this, at least with this lesson and maybe a couple more, we're going to keep working with these kind of strategies that might be a little bit more time consuming, but they're going to help you be able to picture and understand what is happening when we divide something. Okay, we're putting it in terms you guys have been familiar with since kindergarten and first grade: addition, repeated subtraction, things like that, that your brain is already very familiar with, and they'll help get you those connections quicker. And then those shortcuts will make more sense when we do get to use those. All right, so there's our first 2 strategies for division. Great job sticking with me, guys. If you have any questions on your homework, please let me know, and I will see you at our next live session.